Assalamualaikum dan selamat sejahtera. My name is Muhammad Arifin Bersaman. My metric number is 10DJP42012. Okay. Introduction. Electrical Discharge Machining (EDM), also known Electrical Discharge Machining or Electrical Erosion Machining, is one of the most popular for processing method and milling, turning and grinding. Different from the principle of metal cutting, EDM is a process method for machine to touch the electrical quotient effect or pulse discharge between two electrode and workpiece electrode. Since spark can be seen in the discharge process, it is called EDM. According to the different ADM process, ADM can be further divided into WEDM, EDM pressing forming, ADM grinding and boring, ADM synchronous conjugatory machining, ADM high speed keyhole machining, ADM surface strengthening and welding. And last, at present, ADM technology has been widely used to process various high melting point, high strength, and high toughness materials such as quenching steel, stainless steel, die steel, cement, carbide, as well as part which complex surface and special requirement for processing north. Principle of operation. Dielectric medium. The workpiece and electrode are submerged in a dielectric fluid, typically oil and denazed water. This fluid enables electrical discharge and clean away irradiated material. Electrical discharge. A current is applied between the electrode and workpiece. When the voltage reaches a certain level, electrical breakdown occurs in the dielectric fluid in the small gap between them. Heat generation. The high current passing through the plasma channel rapidly heat it to high temperature, causing local melting and separation of the workpiece material. Material removal. The evaporated workpiece material is flushed away by the dielectric fluid, leaving a capacity or mold. This process repeats rapidly, eroding material from the workpiece gradually. Control parameter. EDM can be controlled by adjusting parameters such as voltage, current, plus duration and gap distance between the electrode and workpiece. Shape replication. The electrode shape is replicated on the workpiece by using electrodes of various shape and size. Complex geometries can be machined with the high precision. Final finishing. While EDM is primarily used for rush machining, it can also be employed for finishing operation to achieve tighter tolerance and smooth surface. Frame or chassis. The structure framework that provides support and rigidity to the machine, often made of metal or composite material. Power surface. This could be an electric motor, internal combustion machine, hydraulic system or pneumatic system, depending on the type of machine. Transmission system. Components such as gear, belt, chain, and shaft transmit power from the power source to the working part of the machine. Bearings support rotating or moving part of the machine, reducing friction and allowing smooth movement. Shaft and axles. These cylindrical rod used to transmit rotation motion or torque from one part of the machine to other. Pulley and sprocket. These components are used in conjunction with belt or chain to transfer motion between shaft or to change the direction of motion. Fastener, bolt, screw, nut and other fastening devices hold machine components together securely. Seal and gasket. These prevent leakage of fluid such as oil, coolant or hydraulic fluid can help maintain pressure with the machine. Electrical component which relay, circuit breaker and wiring essential for controlling electrical system with the machine. Control system. These include sensor, actuator, controller and human-machine interface use the monitor and regulate the machine operation. Cooling and lubrication system. This system ensures that the machine operation with optimal temperature range and reduce friction between moving parts to prolong their lifespan.
Electrical discharge machining. EDM or electrical discharge machining is a non-conventional machining process used for machining very hard materials which otherwise cannot be machined using conventional machining processes. This process is also called as spark eroding, spark machining, wire erosion, wire burning, etc. In this process, the metal from the workpiece is removed using high-frequency electrical spark discharge from graphite or soft metal tools, which serve as electrode. Note: this process is only suitable for metallic or conductive workpiece. This process is very similar to how a spark plug works in the petrol engine. It creates an artificial bolt of lighting in the combustion chamber. The electrical energy that it creates is extremely high. In order to create a spark, the voltage at the spark plug is nearly between 20,000 to 100,000 volts. If you are interested in the working of the engines, I have provided a link in the description below. This video will cover the following about the EDM process. 1. Working principle. 2. Construction. 3. Working. 4. Application. 5. Advantages and disadvantages. Working principle. The working principle of the EDM process is based on workpiece metal erosion with the application or spark discharge between the tool and the workpiece. When two current-carrying conductors, that is, anode and cathode, are brought in close proximity, an electric arc is formed between the two conductors, due to which, at the point of contact, a small amount of metal is eroded, leaving small cracks. This spark generates intense heat, causing the metal in this zone of spark to melt and evaporate. When both the electrode, that is, anode and cathode, is made of the same material, the electrode connected to the positive terminal erodes faster, therefore the workpiece is generally connected to the positive terminal, that is, it is made anode. Generally a small gap of 0.005 mm or 0.05 mm is maintained between the tool and the workpiece. The spark occurs where the tool and the workpiece are the closest. Here the shape of the tool is the same as the impression to be generated on the workpiece. To increase the effectiveness of the process, the tool and workpiece are immersed in the dielectric fluids, such as hydrocarbon and mineral oils. Construction. DC pulse generator. This converts the AC power supply into a high-pulse DC supply, responsible for generating a spark between the tool and the workpiece. Tool. The tool should be the replica of the shape to be generated on the workpiece. The tool is connected to the negative terminal of the power supply. Servo motor. As the arc gap is critical, the servo motor is used to control the feed of the tool. Spark generator. The spark generator supplies sufficient voltage for spark generation and maintains its discharge. Dielectric fluid. Dielectric fluid is generally supplied in the form of a jet at the gap between the tool and the workpiece. Deionized water, silicon oil, glycol etc. are generally used as dielectric fluids. Working of EDM process. The tool should be the replica of the shape to be generated on the workpiece. The tool is connected to the negative terminal of the power supply. When the power supply is turned on, the DC pulse generator supplies a voltage pulse between 40 volts to 3000 volts. The workpiece is connected to the positive terminal, and the tool is connected to the negative terminal, and the gap between the tool and the workpiece is filled with the dielectric fluid. When this high voltage power is supplied to the tool, this causes the particles in the dielectric fluid to concentrate, that is, the fluid gets ionized, forming a path for the current to flow from the tool to the workpiece. This intense arc, generated at the tool and the workpiece interface, causes the workpiece material to vaporize. In this process, a small amount of tool material is also eroded. Once the spark is interrupted, the heat is removed by the dielectric fluid and carries the eroded metal particles. The movement of the tool is controlled by the servo motor mechanism, which maintains the gap. Application of EDM. Drilling of micro holes in the nozzles. EDM can be used for manufacturing of gear wheels. Fine holes or slots in the hard materials, used for the blades of the turbines, compressors etc. Thread cutting. Engraving operation on hard materials. Rotary form cutting. Advantages of electrical discharge machining. 1. It can produce complex shapes, which otherwise would be difficult to produce using conventional machining processes. 2. Tolerance of plus or minus 0.005 can be achieved. 3. Good surface finish can be obtained economically. 4. There is no distortion or vibration of tool or workpiece, as there no physical contact between the tool and workpiece. Disadvantages of electrical discharge machining. 1. High power consumption. 2. Excessive tool wear during machining. 3. This process is only applicable for metallic or conductive material. 4. Material removal rate or MRR is very slow. Hope you have understood electric discharge machining process. If you are new to ADTW, click on the subscribe button below, and if you want me to make more such videos, like and share this videos with your friends, also comment your opinion in the comment section below.
Assalamualaikum and salam sejahtera. My name is Muhammad Ammar bin Azhar, matrix number 10DTP22F1029. I will continue with presentation. The topic is application of EDM machining. So, the first one is EDM is to make holes with size that are less than 0.1 millimeter. EDM also utilized in die sinking or die manufacturing, fixtures, and gauging. It also used to make holes in air brakes or pneumatic brakes. EDM also is in press tools and extrusion dies. It also is in die molds for plastics. EDM also apply in die casting, dies, and mold inserts. EDM machining is also used in the repair of worn dies for hot and cold forging and remachining. It also used to make forging dies like connecting rod forging dies. EDM machining is used in sintering dies, also used in calibrating tools. EDM used in the shaping of carbide tools and templates. EDM machining also applied in aerospace, medical, electronic, semiconductor fields, used in the manufacture of hard electrode. Also, it is in the manufacture of micro tooling for micro EDM, micro USM, and such other application for micro machining. Next, I will talk about advantages of EDM machining. The first point is it can be used even in the heat-treated condition and for any hard material. Second point is complicated shapes made on the tool are able to reproduce. Third point is a high accuracy can be achieved about 0.005 millimeter. Fourth, a good surface finish can be achieved up to 0.2 microns. Point number 5 is machining time is not more than the conventional machining process. The sixth point is mechanical stress are not developed in this process because the tool and work do not have any contact. The seventh point is the tool life is longer due to proper lubrication and cooling. Point number 8 is hard surfaces that are also resistant to erosion can be developed easily on the dies. Final point is it can be applied to any material that is electrically conductive. Next, I will talk about disadvantages of ADM machining. The first point is excessive wear of the tool. Next, reproduction of the sharp corner is not possible. Third point is change in metallurgical properties of materials due to the development of high heat. The fourth point is the material to be machined must be an electrical conductor. The fifth point is requirement for redressing of a tool for deep holes. The sixth point is overcut is formed. The last point is expert machinists are hard to find.